Video coverage of the 27th JCT Traffic Signal Symposium is brought to you by Highways News, thanks to our sponsors AGD Intelligent Traffic Systems, Clearview Intelligence, PTV Group, Message Maker Displays, Smart Video and Sensing, SRL and TRL.
Right, hello. Adam and I are going to talk about, well, full vision truth, but whether our signals are reasonable and using different model outputs to assess them and improve the designs. You can skip over the instructions because we've all done that. So we're going to cover TfL's modelling guidance documents, have a look about iterations of different types of modelling, and then Adam's going to run through where it's been used in a few case studies, and I'm going to follow up with an update on the model auditing process. So our guidance documents, we've got two. So the one that I talked about last year was the traffic modelling guidelines. So this is where we set out the best practice guidance for building models, for TfL processes, and other things like data collection and other guidance. So it's a bit of a long wait to get version 4 done after 10 years, but we updated it to cover software updates in that time. And as Chris mentioned earlier about the Healthy Streets approach, we've included a new section as well that covers cyclist modelling, pedestrian modelling, and emissions modelling. And then the counterpart of guidance documents is the model auditing process, or MAP as we love to call it. And this is more the benchmarks and the checks to take through stage by stage of building a model, so base models, proposed models, and then the final scheme assessment sign-off. So yeah, acceptance criteria and then check sheets at the end, and we are currently updating that, and I'll give you a update at the end of this presentation on what we're thinking about including in that update. So one of the other things that we included in modelling, traffic modelling guidance as our new process is how different types of models all interact together to help feed into the scheme assessment process. So we've got tactical modelling, so the highway traffic reassignment, and deterministic modelling, so LINSIG and transit. So they're the models that we use at the start of an assessment, working together. So we've got flows and routings being determined by the tactical modelling, and they're fed with the optimised signal timings and the capacities taken from the deterministic models. So we do a few iterations around between the two of those till the network settles, and then we're able to take flows and routings and the optimised signal timings, feed them into a micro-simulation model to get our detailed journey time outputs broken down by different modes. And these journey times, together with the outputs from the other two models, feed into our overall scheme assessment and make a decision on the design. And now I'm going to pass over to Adam to say how the scheme assessment process has been led or fed into design changes.
So in my team, we're responsible for the operation of all signals in London. And two of the main work streams are the timing review programme, which looks at the existing traffic signals, and then schemes, which looks at new signal installations. So I'm just going to run through a couple of examples of schemes where we've used modelling outputs to determine whether the designs are operationally viable, and also use modelling to refine the designs and improve the performance of the designs. So we're going to start off with Shepherd's Bush Green. We had a cycleway at this location, quite a challenging location, a very large number of bus routes, and also quite a few pedestrians as well. So this was the original design that we came up with. 4-stage method of control, so quite a few stages, and bearing in mind this is on a gyratory, so not ideal. Stage 1 is the cycle movements and the southbound traffic. Stage 2, northbound ahead and right turn movements. Stage 3, all of the northbound movements. and stage 4, the eastbound and the northbound left turn. So this scheme went through the full modelling process with LINSIG, tactical, and micro-simulation modelling. And the results were not really acceptable. So we had very high number of stages, very high waiting times, and also for the cycle movement, which was the point of the scheme, we had very low green times for the cycle stage and very high waiting times. So it wouldn't be an appealing proposition for cyclists. On top of that, as you can see, we were looking at an increase in journey times of up to 15 minutes and up to 7 minutes for buses. So really unacceptable. So we went back to the drawing board and came up with an alternative design. This groups the phases into east-west and north-south. So we've just got 2 stages. So stage 1, the eastbound movements, so eastbound traffic, east-west cycles, and some east-west pedestrian phases. And then stage 2, the northbound, southbound traffic, northbound, southbound cycles, and a north-south pedestrian phase as well. So although this cycle phase is now split up into 2 separate crossings, we've got much lower waiting times and overall a better outcome for everyone. So if we look at the updated results, substantially improved performance compared to the original design. Next example, Battersea Bridge. Again, a very large number of bus routes at this location, quite a high number of cycles as well, and also pedestrians. So this was one remaining junction in London with no pedestrian signals at all. However, there have been a couple of recent incidents, one involving a fatal collision of someone who was jogging, and more recently, a serious collision involving someone on a bicycle. So as a result of this, a scheme now has been implemented on the south side of the junction to add a pedestrian crossing. But there's a strong desire to implement further changes here in order to improve safety for walking and cycling. But as you can see, we have got quite a few bus passengers using this junction and also quite a few vehicles as well. And also, the bridge itself is very constrained. You haven't got a lot of room on the bridge at all, and it's a heritage structure, so quite a challenging environment. On top of that, we have got the high flows, as I said, so very high flows northbound and southbound, also very high flows eastbound and westbound, particularly the eastbound movement. Slightly smaller flows turning left on the southbound and the westbound, and a very small eastbound left turn movement. So, large number of ahead vehicles and quite relatively small turning movements highlighted in black there. So this is the design we came up with. I'll just run through the method control. So we've got hold the left on the southbound and the westbound in order to allow pedestrian movements. And we've also banned the eastbound left turn in order to allow a pedestrian phase on this arm, whilst also retaining 2 ahead lanes. So, eastbound and westbound head movements run in stage 1 and 2, and then the north-south ahead movements run in stages 2 out of the 3 other stages. And the pedestrian and cycle phases run in parallel with the main traffic movements. So we ran this through our tactical LINSIG and micro-simulation modelling, and we're very pleased with the results we've got, considering the substantial changes to the junction. So this scheme is currently in final stages of design, and we're hoping to consult this year. Final example, another cycleway, but this is, again, a very busy gyratory setting with huge numbers of bus passengers and also very large number of pedestrians accessing the 2 London Underground stations at this location. So this was the original design for the cycleway. The cycleway skirts the edge of the gyratory, with the cycle movements operating in parallel with non-conflicting traffic phases. Unfortunately, post-consultation, the scheme was not constructed immediately, and then COVID. Although this created more of an impetus to do more for walking and cycling, unfortunately it also created some financial pressures. So we didn't have enough cash to construct this scheme as it was. So instead, we constructed this temporary scheme, which was built earlier this year. I just want to talk about this offset. This was quite a critical movement, very heavily trafficked. So we knew we didn't want to stop the traffic on the exit because that would cause blocking and prevent traffic from entering the directory from Beedon Road. On top of this, as you can see on the north side of the directory, where we used to have 3 traffic lanes, now we've only got 2 traffic lanes. And this means that the offset from Beedon Road coming onto the internal stop line is also a critical movement, because if we can't get all the traffic from the entry to clear that internal stop line, we're going to have blocking issues because of the lack of stacking space. But unfortunately, an offset wasn't enough to prevent the blocking issues. So we introduced a contingency stage, stage 3. As you can see, stage 3, to the untrained eye, looks almost exactly the same as stage 2. But let's dive into the details. On stage 2, Beedon Road, which is phase B, has a huge phase delay of 13 seconds. In contrast, stage 3, phase B has a much shorter losing phase delay of only 4 seconds, which restricts the amount of traffic entering the directory. This means the traffic can clear the internal stop line and prevent the blocking. Just a quick video. So one of the issues we identified as part of the VISIM modelling was a high number of stops for cycles going around the directory. I think there were originally 5. We've managed to reduce that down to 1 following the modelling work. The one place where we can't reduce the stops is right here on the northwest corner of the directory. This is where we needed to prioritise the directory movement in order to prevent the blocking, as I discussed. So this video highlights the actual situation on the left and the modelling on the right-hand side, which it closely matches. So the 3 conclusions would be, look at your traffic flows and work out where the biggest movements are. Make sure you check, because it might not be what you expect. Second, put the method of control at the absolute centre of your design and then build the physical layout around that as much as you can, trying to get the biggest traffic movements together. Usually this might be the 2 ahead movements in opposing directions, but it may not be that. You've got to check the flows. And then verify with modelling. Modelling will tell you if your design works or if it doesn't work. It can identify potential issues, and it can be used to help you test potential solutions. I'll now hand back to Lucy to run through updates to MAP.
Cool. So, just as a brief preview into what we're working on at the moment with the MAP update. So we asked for survey feedback for what people thought of modelling guidance and the MAP documents existed at the moment. So we reviewed all those comments, had an internal review of all the documents as they are at the moment, and we're just getting to the process of making a plan for what we're going to update. So the main ones that we're considering at the moment are, we're going to introduce 3 new MAP chapters. So one for junctions, so JMAP, one model, our tactical highway assignment model, that's going to have its own map, and pedestrian map as well. We're going to align, obviously it's been 5 years since the last version of MAP, so capture any software updates that have happened in that time that need to be introduced into the checks. One of the things, because we've got a 3-stage modelling process, so there's a future base and a do something in that, and we only had one proposed model check in map, so we've gone for formally splitting out into stage 5A and 5B now, so it can capture any specific the differences between those two steps. Definitely one of the key bugbears was the check sheet format, being able to capture all the comments in there. So we're definitely reviewing that, making sure they're more user-friendly and can capture more comments and probably be more of a reference point and capture a bit more information in there. And yeah, where I was talking about modelling interaction and the different modellings working together, we're going to make sure there's checks between them, between the maps for the different model types, so you've captured the input of information between different modelling types correctly, and just a whole-scale review of the document. And we're aiming, hopefully at the moment, to get it completed and published by the end of the financial year. And that's it. Thank you.
That was great. Thank you. A quick question, first of all, for you, Adam. I looked at how you'd sort of gone to each junction, and you started to work out an improved way of phasing. Do you literally have to start from scratch every time, or after a while do certain junctions take on characteristics where you can say, well, we did this here, so let's start by doing this on this junction, or is it just not even worth trying to do it that way?
That's a really good question. That's a really good question. I'd say it's a little bit of both. Sometimes you can use techniques where you've remembered what you did before, and those things can apply. But sometimes you look at the flows, and those different things come to mind, and you've got to base it around the flows ultimately.
Okay, fair enough. Right. Any questions? So over there, please, and then we've got two people next to each other, and so if we do those, and then if we've got anyone else, while we can get prepared in this side with the other mic. So anyway, fire away, please.
Hi, Adam. That Battersea Bridge scheme, you looked at that. So the modelling looked at traffic counts with the left and right turns, and you decided to ban those turns. How does that affect? Like, what made you take on that choice, and how does that affect? What was the impact of that? Does it affect other junctions down the road, or what happens with that?
So the turn that we banned, it was only actually one turn that was banned, was the left turn. It only had 24 vehicles in the peak hour. The reason we made that decision was that the other option would be, again, to do a hold the left approach. But unfortunately, if we'd done a hold the left approach, we would have then lost one of the ahead lanes. And when we looked at the flows, we had over 800 vehicles doing that movement. And to get them to use one traffic lane would have been an incredibly difficult decision. So we felt the impact of a few vehicles reassigning would be much less than having to halve the capacity for that approach.
And then as part of the tactical modelling, we were able to see, we banned it in the tactical model, and then that would assess where traffic would divert to or which routes they'd take. So we were assessing it using that modelling.
Thanks.
Okay. Mark?
I was actually going to ask almost exactly the same question, adverse impact on traffic by changing to a banned movement, but I don't think there's any need to repeat it. Thank you.
Okay, thank you. Anyone else? You answered all the questions really well. We've got one there. Yep, sorry.
Mark Roxburgh, National Highways. When you banned those turns, did you monitor the effect of that ban and how effective it was in terms of violations? And what did you do if there were any to address that?
That would be something we would look at. I mean, this scheme hasn't actually been implemented yet. We're in the final stages of design, but that's something we would monitor, yeah. But I mean, the traffic assignment modelling suggests that there's not a major impact because obviously it's a very, very low movement.
Fabulous. Right. Well, thank you very much to Adam and Lucy. That was really, really interesting. Thank you.